Hello everyone, welcome back. This is Naidu from Techno Legal Forum. Last class we discussed about encryption. In today's class we are going to discuss about hash function or hash algorithm. Before we do that, let's quickly recap the encryption what we discussed yesterday. Okay. You have a sender, you have a receiver. Between them, internet. So they are somewhere across the globes. Let's assume these two are nodes across the globe. The traffic flows through the internet. Okay, so this is the assumptions we have made. Suppose sender want to send a plain text, a text message, let's say as an example, hello Bob. What he does is he encrypts it. Encrypt is nothing but a mathematical operation, okay, kind of computation using algorithm and a secret key. This is the key which the sender and the receiver already know. They've already shared this key by some other means, by some other secure means. Okay, these are the three assumptions. Okay, the text or the message is encrypted using algorithm and the key to convert into a unreadable text. We also call it as ciphertext. See, we can't make out what this. Suppose if I give this one with, suppose you don't know this. Okay, if I give this, you can't able to make what exactly it means. So that is the purpose, because this will be sent through the internet. Internet by default is an untrusted network. Untrusted. There are lots of hundreds of system eavesdroppers, hackers who capture the packets which are flowing in the internet using sophisticated software tools. In that packets, they will able to read out the messages sent by the sender and receiver if there is no encryption. Encryption helps in preventing that. If you make this as like the information into a ciphertext, even if the attacker captures it, he will not able to make it what it means, right? So that is the whole purpose of encryption. Once the ciphertext get received at the receiver end, receiver system, we have a similar process, decryption, and the algorithm and the key. Remember, this is the key, is the most important part of this whole encryption process. If this key is lost, then is as good as hackers can access. So now securing the key is a very important aspect. Using this key and the reverse algorithm, they will able to convert the ciphertext into plain text. This is a text which Bob Alice has sent. So this is the, so this application of encryption is CIA. You might have remember this. This is called security triad. TRAID. So C for confidentiality, I for integrity, A for availability of the data. So this is what every organization try to implement: confidentiality, of the data. See, it's confidential. Once you convert the data into ciphertext, nobody able to read other than the intended persons. That is about confidentiality. Integrity means you are sending hello Bob. Okay. When it travels across the network, when it reaches, it should not become something else. Instead of hello, it will be. I'm just giving an example. Hello B or C or something, which is even slight variation to any variation. The data what is sent should be received as is. Okay, that is called integrity. If there is a manipulation in the data, once it reaches, then integrity is lost. So we have to ensure integrity. So that is the chapter we are going to. There is, like encryption, we have another technology called hash function, which will ensure the integrity. We will see that. The last one we are not covering in this session, but it's availability. Availability of data means when the data is, when the resource need to be accessed, it should be available. It should not be offline. So this is all kind of redundant systems we build. Redundant systems and multiple systems having the same copy of data. Even if one system goes down, other system able to provide that data instantly in milliseconds. So that is not ensuring availability. So these are the, we call this CI triad. It is represented like a triangle. CIA. So this is, you should be able to explain what is a CI triad. How do you implement this one? Confidential is implemented by encryption, integrity is implemented by hash technology, and availability is implemented by redundant systems, right? There's so many methods, but this is the understanding. Okay, now let's move to the hashing. So very important. I've written down the lines of explanation just to make, and highlighted some words to make the significance and the critical part of understanding this hashing algorithm. So basically, hashing algorithm takes a piece of data. The data can be small size or very huge. So that's why it's called variable length. Remember, this is very, very important part you have to remember. Hashing algorithm takes a piece of data which can be variable length. Okay. For example, password. It can be a password. It can be a 1 giga movie file. 1 giga means how much? I believe it is 10 to the power of 9 bytes. Okay. When you talk about password, suppose my password is like, let's say 40 yes. So how many? Hardly 10 characters. So when you when you look at the size of this in terms of file, maybe less than 1 KB, kilobytes. Where is 1 KB? Or is 10 to the power of 9 bytes. So why I am stressing here? Okay, why I'm stressing variable length. So hashing function can take very minute file as your password, or a huge file such as your, if you record one movie, okay, and save it in your disk, what could be the size of that movie file? Okay, it could be huge, right? It can take both types of inputs, huge inputs. Okay, very important aspect is first part, variable length input. Second part, fixed length of characters called hash. Even if you, it means even if you give 10 characters of your password file, the output will be of, for example here, 64 characters, hexa characters. Well, I will explain that. Hexa character 64 hexa characters. Even if you give a small file password as an input, you will generate the output into fixed length string of characters called hash. The string of characters is nothing but hexa characters. So that is, hexa characters means 0 to 9, then A to F. Okay, hexadecimal, binary, binary 0 1, decimal 0 to 9, and hexa 0 to F. Okay, so you can do the conversions and all. We'll not go into those aspects. The point is very important. Even if you give small data, you will get 64 characters. Even if you give 1 giga movie file, still you will get 64 characters. So the output length will not vary. That is very critical. Why, I'll tell you, is very important. Okay, when we go for its applications. So okay, hashing algorithm takes piece of data of any variable size and mathematically scrambles it, just like encryption we say now, scrambles it into a fixed length of strings. And the algorithm which we are going to discuss is 256 bits. See, 256 bits can be represented by 64 hexa characters. This 256 bits can also be told as 32 bytes. How? 1 byte is equal to 8 bits. So 256 divided by 8, you get 32 bytes. So whether you say 32 bytes or 256 bytes or 64 hexa, one and the same when it comes to the computer. Okay, computer language. See how this fixed length, here is a 64 characters here. You can see here hexa characters. You can see here numbers. You can see somewhere, you can see E here, F you see here. So hexa is nothing but 0 to 9, then A to F. So just remember, you have 64 hexa characters for every input we give for that hash function. Let me okay, now hashing algorithm was initially MD5, message digest 5. These are the algorithms. Okay, that how it that algorithm is one which takes the input and converts into variable input into fixed output, right? So these were the series of algorithms developed over a period of time. What we are discussing is SHA-56. Okay, secure hashing algorithm, SHA, secure hashing algorithm, 256 bits. Output will be 256 bits. You can see here. This is it. Or in terms of bytes, in terms of hexadecimals, 64 characters, 32 bytes, 256 bits, one and the same. So for every input, regardless of the size of the input, the output will always be 256. Even if it is small input, output will be 256 or whatever. We can let's start using only this one, hexa, 64 hexa characters regardless of the input. So these are the things. And MD5 is message digest version 5. So now this has become insecure, no longer used, because the computer speeds, processor speeds and computational speeds have increased over a period of time. As these speeds increase, the breaking of that, what is that, you can able to figure it out things. So number of possible computations the processor can do much less those times. Nowadays if you use this one, the hacker will able to figure it out what we are trying to scramble the input. So this is much stronger. Okay, so we are going to discuss about this. Okay, how it works. So this makes understanding much easier. Pay attention please. Input, remember, any length. So example, if you see here, password 123. This is also password. Then what is the difference between these two? Pay attention to this first letter. First one is small case, second one is uppercase. Hello world. All this will go to hashing algorithm. What is the algorithm being used? Secure hashing algorithm, 256 bits, means output will be 256 bits or 64 hexa X characters. So considering this, the hash of password 123 is 60. This here it is written here, it will be length of 64 hexa characters. What will be the length of, see this is also password 123, password 123. Even though both are same word, right? The fact that it is a capital P here, its hash will be totally different. Can you see here 4A2C811, here EF and R. Just even if you put a small dot here, the hash will be also be totally different. It will not be no resemblance when the input doesn't have a dot, and when after the input has password 123 dot, it will have a totally different unique hash. Okay, so it means no different, this is one of the property, no different password here. If you are giving a different passwords, the output should also be different. At any cost, you should never produce the same hash. Okay. Now, after understanding these things, you might have think, okay, what is so bigger application of hashing? Okay, let's see. In earlier sessions, we discussed to authenticate, we send a password from system A to B, which is a server, and this is a client. This server, we send a password. Password will be captured by this server, and it verifies its database against, of course, username and password will be provided. It verifies the username and password. Password is available, it allows the access for the person who connected from this system, right? That is what we know. What if I say I don't want to give the password at all, but still I should be able to get authenticated? Isn't it surprising? I am not providing the password at all, yet I am able to get authenticated. How it is possible? So, two things it will serve. One is, you are not sending the password over the internet, right? You are only sending a hash of your password, right? The hash which travels over the internet, we are no longer here, we are not talking about encryption. The hash which is traveling over the internet, even if you capture it, okay, you cannot recover the password. It's not encryption where you, once you have the key and you do the decryption and you'll get the original text. So that is the something uniqueness. It's a one-way street. We call it one-way street. You can only scramble the password or the text or any file what you are sending into a 64 character wide hexa string, unique string. Using this, you cannot get back. That's it. There is no way you can get back. That is the concept of hashing. That's why you cannot reverse the hash. Okay, now coming to the application. I told earlier we used to send a password over the internet. Suppose we don't do encryption, we send a password over the internet. Password can be captured by hackers, eavesdroppers, using sufficient tools. Here, now let's see the situation here. This password is fed to the hash. Hash will give this. This hash will be sent by system A or the person sitting here to the intended receiver. We know that B has already have the password. See, in earlier case, it takes the password, verifies in its database. If the password is allowed, this person is authenticated, right? Here we are sending the hash of the what? It's a password. Now B takes the hash, it keeps some place, it keeps it somewhere. What it does, it since it is already having the hash, it is already having the password, right, in its database, it performs similar hash function. It takes the password, feds into its own hash function, it generates hash. It takes the password, put it to the hash function, it generates 64-bit 64 hexa characters. Remember, same password will generate same hash, correct? Same password will generate 64 character hash. Now whatever the hash it could generate at the destination, it compares this hash with the received hash from the A. If both are matching, it is understood that the passwords are correct and it allows. Now you are understanding the appreciate its future applications. You are not sending a password, by that you are preventing the somebody hacking that. Secondly, even if that get hacks, as I said, with the hash you cannot regenerate the original text, so it serves excellent purpose. Remember, here I am talking about password, small text. See its real, you will appreciate its real application. Now I have 500 pages confidential document, application, okay, software, image, whatever it is. Remember, variable, any length hash function takes, any length, any different, regardless of its size. What is the biggest advantage here? Now you are taking, let's consider 500-page confidential document. This document needs to be sent from person A to person B. Nobody else should be able to. Okay. Password wise we are able to say confidentiality and all, but here, since it's a document, first step is create a hash of the document. Remember, even though it is so much big size, still I'll get unique 64 hexa characters, just like here. Now I generated, for this document I generated 64 hexa character. Okay. Now B person has a copy of it. Okay, a copy of it. Here intention is, when you are sending a document over the internet, it should not be manipulated. Remember, even a small dot, for example, you take a password 123, if I just put one dot, this 64 character hexa will completely change, right? Now I am sending this document, okay, over the internet along with the hash, or hash might be sent separately. Let's say this person doesn't have document. For now we will consider this person doesn't have the original document. Original document is sent, then hash of it also sent. What this person want to, whatever he is receiving, the objective is whatever he is receiving should be original document, right? It should not be manipulated. Suppose if there are a lot of financial details, if somebody hacks this document and changes these values, if it's an invoice, okay, you're sending to the client for the payment, in the contents of the invoice the amounts can, if assuming if it's get changed, there's no way this B can able to know, right? So when you are sending this document, original document with the correct values, you create a hash. So it will have a 64 character hash unique to that document. When this person receives this document, okay, he will also generate hash function. Okay, he generates hash function and he generates separate hash 64. The hash what he generated, the hash which was sent along with this document should match. If there is no match, it means that document has been manipulated by third person, someone sitting between these two guys. Understood? Simple. See, you have sending a document or application or a pirate. Okay, let's take example of movie. A movie is released, blockbuster movie. Okay, yet to be released. Now this movie is shared between the shared over the internet, let's say. Okay, it has a unique hash because the original movie content will have a corresponding hash. Movie is sent, shared over the internet. The people who are receiving movie should receive the original copy, right? That is what we are paying for, right? How do you figure it out? He receives hash plus this movie. He performs same operation here. If the hash value change is different than the hash which was sent, it means somebody has changed the contents of the movie. Then it is easy to figure out. It's nothing but data integrity in CIA. Data integrity is implemented using hashing algorithm. Okay, at this point we'll pause and we will see some of the applications of hashing algorithms and also some problems which were noticed in MD message digest 5, which are overcome in this SHA 256. But with the advent of so many technologies, how secure is this one? How long it can last? Especially the technology related to quantum computers. It's a totally different way of computation. Billions, trillions of operations will happen. The current world laptops, Intel processors, all this will be kind of far behind with the technology. With the technology what are the implications of this hashing algorithms and even encryption, that we will discuss in the next class. Thanks for this joining this call, and we will catch up in the next class. Have a rest of good